Hey Pre-Calc Honors, this is a video here to talk about our next part of vectors, which is called the cross product. So with the dot product, we had sort of a multiplication kind of idea, like vector A dot vector B, and the result was a scalar. The idea now of a cross product is it's a type of multiplication of two vectors where the result is a vector. And it's actually it's kind of a special vector. It's a vector that is perpendicular to the two original vectors. Okay, so just let's think about that for a second. If I had on a flat piece of paper vector A over here, and let's say I had vector B down here. If I do the cross product of those two vectors, it's going to be a vector that's perpendicular to both of them. Well, those two vectors are both on a flat plane, like a flat piece of paper. So the only way I can get a vector perpendicular to it is if I have a vector that's coming straight out of the page, straight up. And so we get a third, we have to do cross product in 3 dimensions. So that would be, we call this A cross B. And that is straight up out of the paper. AKA perpendicular to both A and B. Forms a right angle there, forms a right angle there. Okay, let's get into the math behind it. If you ever falling behind, just pause the video, catch up. All right, so let's say we have two vectors. We got vector u is a1, a2, and a3 are its components. Vector v is b1, b2, and b3 are its components. So there is a formula for this, and it says that u cross v, which that's how we say it, u cross v, and we write it u x v, is equal to, and then it's this kind of mess, a2b3 minus a3b2, a3b1 minus a1b3, a1b2 minus a2b1, and yuck. Like, that's kind of gross. So, I mean, sure, you can memorize that if you want. I don't recommend it. I've got a better way. And in order to do that better way, we need a quick reminder about matrices. Remember these from Algebra 2 last year? Basically kind of a way to have some rows and columns of different numbers. So like this here is a 2 by 2 matrix because I've got 2 rows going across and 2 columns going up and down. And this is a matrix -4, 6, 1, 2. We're going to do a whole chapter on matrices going farther than you did last year next. But before that, we just have a kind of a quick matrix skill that we'll use to help us with this cross product idea. And it's something called the determinant of a 2 by 2 matrix. And I don't think you've seen that before necessarily. So we have this matrix ABCD, matrix A. Then the determinant of A, which there's this kind of notation, DET capital A means the determinant of A, which equals, and then another notation you'll see is it kind of looks like absolute value bars instead of the regular like square brackets, A, B, C, D. And the way that works is it's A times D minus B times C. And so one thing I've seen done is you kind of like multiply up from the bottom. If you do this, A times D, and you would write it up here, you would write it up here, AD, and then you multiply up from the bottom for the other one, CB, and you would write BC, and then you just put minus in between. Okay. AD minus BC, that is also sometimes known as the inner product of a vector, or excuse me, of a matrix. So this calculation, and truly it's just a calculation that you can do with any 2x2 matrix, is related to how we will find the cross product. And the way we do the cross product is actually doing this determinant thing, but for a 3x3 matrix. And we will dive into this more next chapter. For now, it's going to be just kind of modeling a process that I show you. So this cross product is going to equal, and see those the vertical bars, that means determinant of a matrix that is set up with ijk across the top, and then vector u goes across the middle and vector v goes across the bottom. So let's take a look what this looks like. And again, if you ever need to, just pause the video to get caught up on what you're writing down. So here's the same thing up at the top there. So let's say we call vector u 1, -3, 2. And then vector v, we're told, is 4, 0, -2. So now we're going to fill in this matrix determinant. So u cross v is equal to, and then you have this 3x3 matrix. ijk goes across the top, and yes, that's our I hat, j hat, k hat. You can throw hats on top. And then u across the middle, so 1, -3, 2. You put the 3 components down. And then 4, 0, -2. So what I'm going to ask you to do is just sort of follow along with what I do here and kind of try to see the pattern of it. And then after you do it a couple times, you'll be like, oh, it's the same thing every time. I get it. So what we do is we say it equals the determinant of -3, 2, 0, -2 times I hat minus the determinant of 1, 2, 4, -2 j hat plus the determinant of 1, -3, 4, 0 times k hat. Okay. So notice when I did the determinant for I hat that goes in front of I hat, I've basically blocked out the row and column involving I, and I use those remaining 4 numbers, -3, 2, 0, -2. For j, I block off the middle column and the top row, the ones involving j, and what's left over is the 1, the 2, the 4, and the -2. Then for k hat, block off the right column and the top, and I'm left with the 1, -3, 4, 0. Okay? And so then, let's see if I can do this there. So now we do that determinant math. We know the formula for the determinant is that you multiply the diagonals and subtract them. So I do -2 times 3, -3 is +6 minus, and then I do 0 times 2 is 0. That's times I hat minus, and so now it's -2 times 1 is -2 minus 4 times 2 is 8 j hat plus 1 times 0 is 0, 4 times 3 is negative 12, so it would be 0 minus negative 12 k hat. And that's going to equal my answer, 6i minus, and that's minus negative 10, so that's going to be plus 10j, and minus negative 12, so that's plus 12k. Or you could say that that's the vector 6, 10, 12. Okay. What's cool about that vector is it is perpendicular to both u and v. So if let's test this out. If a vector is perpendicular, if two vectors are perpendicular, we know that when you do their dot product, they equal 0. So let's test. I want to do vector u dotted with vector u cross v. And it should equal 0. So let's test it out. That would be 1, negative 3, 2, dot with my 6, 10, 12, which equals 6 plus negative 30 plus 24, which equals 0. And therefore those two are perpendicular. We could do the same with v and the cross product. We would see they are also perpendicular. Okay, almost done here. We're just going to try two more. I'll kind of once again go through the first one. If you want to pause it, try it on your own, you can. All right, so let's set up the matrix. A cross B, we set ijk across the top. And then on the inside is the two vectors. So A is negative 6j 2k, which means it's 0i negative 6j 2k. Gotta watch out for that. And then B would be 1/2 I 1j and 2k. Okay. And so now I split that into those determinants. So that would be determinant of, so for I need the negative 6, 2, 1, and 2, kind of looking at that bottom right, times I hat minus, and it's always minus for the second, so it goes positive, negative, positive, minus determinant of, and then I skip the middle, so it's 0, 2, 1/2, 2, j hat, plus, positive, negative, positive, and then absolute, or determinant of, skip the right, so 0, negative 6, 1/2, 1, k hat. And that's going to equal negative 12 minus 2, multiplying the diagonals, I minus 0 minus 2 times 1/2 is 1, j hat, plus 0 times 1 is 0 minus negative 3, k hat. And so I get my answer to be negative 14i plus j, 1j, or just plus j, plus 3k hat. There's your cross product. So what I'll have you do this time is definitely pause it, try to do 2, and come up with your answer, and then unpause it and you can check. And yes, you can probably do a little of this in your head, right? So try it out, see what you get. All right, see how you did? Negative 9i minus 25j plus 20k. That's all we're going to do here, so you can try out your homework now. And then we'll kind of work on this more the next day in class. Thanks for watching.